So Nick is interning with us for the second time. He was with us last summer as well. He's from, let me try my best New England accent, Worcester Polytech. And so we've heard today about the need for sensors, right? The need for information, how we fuse that information, not only to tell us the state of our system, such as something like mice have, but how we use that information to navigate, right? Josh just talked to us about common filtering and how that can be applied to navigation. So now we've got a payload, we've got a system that's flying around, but we might want to create safe boundaries for that system. Sort of a safe zone and not. So what Nick is going to talk to us about is geocontainment.
Yeah, so like she said, I'm Nick Woodward. I've been brought on by the Autonomy Incubator and Dr. Mark Motter, specifically for the summer project of creating a geosafety net for vehicle dynamic control, at least for here in the incubator. First, I'm going to talk about a little side project I had while I was here. I got the chance to work with the new 3D printer that the incubator brought in, so I got to make a bunch of stuff at the request of Danette Allen. We've got Pac-Man, Ghosts, Heart, Don't Ask, and of course Banana for scale. And we actually, they work. The 3D printer actually does what it's supposed to do. We have now an official banana for scale, at least for within the Autonomy Incubator. More towards my main project. The Autonomy Incubator is made up of a wide, diverse group of student interns, engineers, and researchers from all walks of life and learning. And we all come together to work on, as it was put, to imbue machines with the same type of intelligence that we expect from human beings. And one important distinction before I move on that I want to make between automation and autonomy is automation is the relegation of tasks, while autonomy is the delegation of decision-making. One example is automation is akin to using a toaster to make toast. You put the piece of bread in, you turn it on, you let the toaster do its thing, but it only really does one thing. That's automation. And you can tell a dog to go fetch a newspaper, but you don't tell the dog how to go to the front door, how to get out of the house, how to go down the front drive, how to pick up the newspaper, come back, drop it off. That's a very important distinction. So in the Autonomy Incubator, we have a wide variety of projects going on with everything from running search and rescue training under trees-ish. Dancing with drones in sort of a security delivery standpoint. We deal with visual odometry and sensors, and so there's a lot of different sort of areas of research happening with a lot of different vehicles. Now we've got everything from the very large electric Mars Flyer, which you've already seen, all the way down to our newest addition, the Crazy Fly, which really won't do anything if it hits you. The Mars Flyer, on the other hand. We've got AR drones, bottom left, and the Green Machine, bottom right. But with all of these different vehicles, we don't have a software-side security system implemented. We have physical security systems. We've got the safety net that everyone's going to stand behind when things fly. Everyone on the other side of the safety net wears safety glasses. If they need a helmet, we've got helmets. But we have nothing on the software side that's consistent through all of these platforms regarding protecting the vehicle, the environment around it, and any user that might come in contact with it. Which is where I come in, geocontainment. My project goal is to implement a safety system to ensure the security of autonomous flight operations through reinforcement of vehicle dynamic control. Well, ideally, when we're flying our vehicles, we want everything on board that we can get. For instance, we want all of our sensor readings to occur on board. We want all the decision-making, trajectory generation to flight. Everything should happen on board for a truly autonomous system with whatever external factors, such as GPS, providing that as need be. But in the incubator, we're utilizing the Vicon system with the Bonita cameras as of right now to sort of emulate GPS because we're in an indoor setting. As Currently, however, we have only the sensor readings and trajectory execution, sort of what the motors do to control the vehicle, happening on board. And externally, we've got the GPS readings provided by the Vicon system, and decision-making, trajectory generation, and vehicle commands all happening sort of on an off-board computer. And this is important because it's where my safety block fits in. I developed a program that sort of does its best to protect the users who are outside the vehicle's area, designated area of operation from the vehicle doing anything it's not supposed to be doing. My vehicle sits on the output of the vehicle controller, taking in the control output from the vehicle controller and the current vehicle's position, and deals with it on its own. For the Incubator specific implementation, the Vicon system provides essentially a dome for the vehicle to operate in safely. My program, as of right now, is currently a Simulink block sitting on the vehicle, its most recent vehicle controller's output. It's connected to the vehicle via DDS system, which means it's not on board, which can be an issue. And will need to be added to the actual vehicle in the future. And sort of the significance of the fact that the safety system that's supposed to control whether or not the vehicle does something safe once it's out of the designated area operation is this sort of concept can be applied to having a semi-autonomous system being connected to sort of, for instance, a radio transmitter. The idea being that the human operator has the opportunity to take control over the vehicle at any point, but if the vehicle leaves that range, you're no longer able to take control of the vehicle, which of course means that the vehicle has to be able to either re-enter its area of operation as designated by the remote, or has to be able to land on its own without hurting anybody. My particular Simulink block reads the current state of the vehicle from the Vicon information and interprets the commands that are being sent out by the vehicle controller. Then modifies the commands if it decides to do so to the vehicle, and that depends on its current and potential state, and outputs those commands as necessary. The Simulink block, this more general version, has its own set of system constants. Position information comes in, the vehicle controller sends its information in, then my function runs, spits it out into a state machine, which either determines whether or not the vehicle controller commands continue moving through, or it enters a set of pre-programmed states. There are 5 designated states based off of 4 different criteria. You can either, the program will either let the vehicle commands pass through, the block doesn't do anything. It will institute a hover, institute a recovery attempt, institute a landing protocol, or just shut off the motors in an emergency landing scenario. These are based off of the 4 states I mentioned. You have the sort of go area where the vehicle is supposed to be, no issues, it flies around, does whatever it wants, my block doesn't do anything. Then we have a soft border. The soft border is in between the sort of very limit of the area of operation and sort of the buffer zone based on the specific vehicle that's being run. This area is where my controller will sort of try to influence the movement of the vehicle towards that hard border in order to sort of dissuade any attempt made by the vehicle controller to leave that area. The hard border is the absolute limit. Once the vehicle crosses that hard border, I will assume, or the program assumes, that there's nothing that can be done aside from institute a recovery attempt to get the vehicle back into the area of operation, or shut it down. Try to reduce any risk of anybody coming in contact with it in any way that might be damaging to the individual. And this is sort of where the tie back into the onboard system comes in. Because when the vehicle leaves that area of operation, if I can't dictate that command to the vehicle to land, then there's nothing my block can do. So the importance moving forward for this particular block is to get it on the vehicle as soon as possible. And thank you. I especially want to thank Dr. Mark Martyr, who has brought me on into NASA as summer intern for the second year in a row, the entirety of the Autonomy Incubator, especially Dr. Danette Allen for letting me join this.
Well, it's been our pleasure. Thank you.